Today we are working in Chapter 1, Lesson 5, Graphing Ratio Tables. We are on page 51 and we will be checking and working through problems 1 through 7 together, pages 51 and 52. So number 1, the table shows the total time it took Samir to read 0, 1, 2, and 3 pages of the book. The table also lists this information as ordered pairs, number of pages, comma, total minutes. So when we look at our table over here, we have 0 pages, 0 minutes. That gives us the order pair of 0, 0. We can go ahead and graph that ordered pair. At reading 1 page took Samir 4 minutes, so 1, 4. And 4 is not a number on our labeled on our axis, but we can see 0, we can see 5. We know we'll be 80% to 5. So just about right there, maybe slightly lower. And then we have 2, 8. So 2, 8. Again, 8 is not on our, isn't labeled on our axis, but we know halfway between 5 and 10 is 7.5. So 7.5 will be halfway. So 8 would just be a slight bit more than halfway between 5 and 10. And then we have 3, 12. So we can plot that point, 3, 12. Okay, so those are the 4 points. Again, we have the ordered pairs are listed in this last column, 0, 0, 1, 4, 2, 8, and 3, 12. Okay, so that is the graph of that ratio table. Describe the pattern in the graph. Well, we can see that for every page Samir reads, it takes him 4 minutes. Okay, next, we're looking at Ken's home supply. So Ken's home supply, I'm just going to slide this page up a little bit, charges $5 for each foot of fencing. The total cost for 1, 2, 3, or 4 feet of fencing, make a table for each store that shows the total cost for 1, 2, 3, or 4 feet of fencing. List the information as ordered pairs, and the ordered pair should be listed as feet of fencing, comma, total cost. So we have 2 different home supply companies. We have Ken's and we also have Wayne's. So Ken's home supply is charging $5 per foot of fencing. So for Ken, if we want to write our cost as ordered pairs, remember X is our feet of fencing and Y is the cost. So 1 foot of fencing at $5 per foot will be $5. So 1, 5. 2 feet of fencing at $5 per foot will be $10. So 2, 10 as our ordered pair. 3 feet of fencing will be $15. So 3, 15 for our ordered pair, and 4 feet of fencing at $5 per foot will be $20. So 4, 20. And then moving over to Wayne's warehouse is charging $6 per foot of fence. So we'll have 6, 12, 18, 24. So as ordered pairs, these would be written as 1, 6, 2, 12, 3, 18, and 4, 24. And then this says graph the ordered pairs for each store on the same coordinate plane. So we'll go ahead right here and we'll start with Ken's home supply. We have 1, 5, 2, 10, 3, 15, 4, 20. And I don't have a different color pen other than blue, so I'll use pencil for Wayne. So Ken, Ken's Home Supply is in blue, and then Wayne's Warehouse will be in pencil. So we can go ahead and plot those 4 points for Wayne's Warehouse. 1, 6, 3, and 4. That pencil shows up okay on the camera. And then number 5 says, using the tables and graphs, write a few sentences comparing the ratios of amount charged per foot of fencing for each store. How is this shown on the graph? So Ken is charging only $5 per foot, and Wayne is charging $6 per foot. So his slope, Wayne's slope, because his price is higher, the slope of his line is steeper, or the pricing is steeper. So since we can just kind of generalize that and say, since Wayne charges more per foot, the cost of the fencing goes up at a faster rate than Ken's. So let's just go ahead and write that down. Since since Wayne Wayne's Warehouse charges more per foot, the price increases at a faster rate. And if you look at the graph, you'll see in the graph too that they have Wayne, which has the pencil, the points that are written in pencil, has a steeper increase than Ken's, which has the blue points. Let's go ahead and turn to page 51. So justify conclusions. Patty's Pies made 2 peach pies using 10 cups of peaches. They made 3 pies using 15 cups of peaches and 4 pies using 20 cups of peaches. Predict how many cups of peaches would be needed to make 9 peach pies. So we can see that 1 to 5 ratio. So we see 2 times 5 would give us 10. 3 times 5 will give us 15. 4 times 5 will give us 20. So 9 times 5 would give us 45. So we know we'll need 45 cups of peaches. To make 9 pies. And let's just go ahead. We have a lot of really nice workspace here. So let's go ahead and make a ratio table to organize our information about the pies. So we can make our first row of our table number of pies. And our second row will be cups of peaches. Okay, so we know that she made, or Patty's Pies, excuse me, made two pies using 10 cups, so 2 to 10. 3 pies needing 15 cups, so 3, 15, and then 4 pies needing 20 cups, so 4, 20. And then we're asked to find out how many cups of peaches will be needed for 9 pies. So we'll go ahead and we can continue the table with 5, 6, 7, and 8 if we want to, or you could just go directly to 9 because you'll be able to see the pattern. So I'll just list all of them so we can be very thorough. Okay, and then we can see that we can see a linear relationship first of all, but we can also see this times 5 ratio. So 2 times 5 gives you 10, 3 times 5 gives you 15, 4 times 5 gives you 20. We can jump all the way down here to 9. We see that times 5 in our ratio table. That's our rule. So 9 times 5 is 45. We can go ahead and do that for all of these. This would give us 25, 30, 35, 40, and 45. So you can continue the table the same way that we taught you in previous years in more elementary math. Or you can recognize hopefully you see that pattern, that 1 to 5 ratio. So 1 pie would need 5 cups. If we were to add another row right there, I'll just squeeze that in. And so explain, we can just say there is a 1 to 5 ratio for pies to cups of peaches. That could be our explanation. There is a 1 to 5 ratio, and that is pies to cups of peaches. Okay, moving on to number 7, multiple representations. The golden rectangle is a rectangle in which the ratio of the length of the width of the, the ratio of the length to the width is approximately 1.618, so 1 in 618 thousandths to 1. This ratio is called the golden ratio. Make a table, so part A, make a ratio table to show the approximate lengths of golden rectangles given widths that are 1, 2, 3, and 4 units. Okay, so given widths that are 1, 2, 3, and 4 units, that's right from our instructions. And so it's a 1.618. So if the width is 1, the length is going to be 1.618. If the width is 2, the length is going to be 3.236. So 16 doubled is 32, 18 doubled is 36. If the length is 3, we'll get 4.854. And if it is 4, we'll get 6.472. And then we can write these as ordered pairs. So as ordered pairs, we're just putting the parentheses around them and putting a comma in between. So we have 1.618, comma 1, 3.236, comma 2, 4.854, comma 3, and 6.472, comma 4. And then part B asks us to graph the ordered pairs on the coordinate plane. So we can, we'll need to estimate with these x values. So here's 1.618 would be just a little closer to 2 than it is to 1. And then 1, so we're approximately there. 3.2362, so here's 2, there's 3, so 2.236 will be about 20% of the way from 2 to 3, so pretty close to 2. Sorry, pretty close to 3, excuse me. And then up to 4.854 at 3, and 6.472. So right about 6.5 and 4. Okay, and then part C, how does the area of each rectangle change as the dimensions change? So the area will increase. Okay, so the areas increase to or let's say as well, the areas increase as well. Okay, so the area, when your width is 1, your area would be your length times width, so 1.618. When your width was 2, that's going to be 2 times 3.236, so 6.472. When your width is 3, it'll be 3 your length times width, so 3 times 4.854, so 14.562. And if your width is 4, your area is going to be length times width, so you'll get 25.888 for that. You're just multiplying 6.472 times 4 to get that. So as the size of each rectangle increases, the area will increase as well. So those were just a few sample problems for us to do some filling out ratio tables, as well as representing those ratio tables with graphs. So again, that was chapter 1, lesson 5. We just went over problems in the independent practice, problems 1 through 7. So that was pages 51 and 52.